Top, à 0 moins 4 minutes.
He calls out all the major events, and he's just called out the beginning of the last 4 minutes, the synchronized sequence. Computers are now controlling all the final checks in the countdown, and they manage an impressive list of operations. All of that information is sent to these boards. We call these the status panels, and they are representing the 3 main systems across the base: the rocket and pad, the satellites, and the range. And a quick translation for you. The base at the top, logistics, safety. Mesure is the telemetry. Localization is radar. Telecoms, obviously. Ensemble de lancement is the launch, the range. And then, of course, the Vega launcher, the weather, and our satellite. The teams in the Launch Control Center are watching over all of these operations. The Launch Control Center is based close to the pad, about roughly 1 kilometer. And they're in a protected blockhouse. And they are, of course, concentrating hard at this point just before the launch. Once Vega has lifted off, it will take approximately 55 minutes to deliver the Mohammed 6A satellite to its orbit in space. And after that, the satellite will continue orbiting on its own, on a sun-synchronous orbit. 2 minutes now, Vega standing tall. We have 3 working launch zones here at the Guiana Space Center, 1 for each rocket. And this is the Vega launch site. It's called SLV, Site de Lancement Vega. It was built on the first Ariane launch pad. That was Ariane 1, which launched on the 24th of December 1979. Some of you will remember that. The final countdown started just over 9 hours ago. The mobile gantry was withdrawn about 3 hours and 15 minutes ago. It took 45 minutes to do that. Coming up to 1 minute.
À tous de DDO, attention pour moins 1 minute. Top, à 0 moins 1 minute.
We are 1 minute to launch. Our very best wishes to all the teams, to the Mohammed 6A satellite teams and the Kingdom of Morocco, to the industrial consortium led by Thales Alenia Space and Airbus, and to the teams on the ground who are waiting to take over the satellite. Let's sit back now and watch the launch. Our very best wishes.
À tous de DDO, attention pour les 2 comptes finales. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, top. À l'image P80, décollage.
They are off. The Mohammed 6A satellite is on its way. Vega number 11 is blazing a trail across the equatorial skies over the Guiana Space Center. He's telling us the propulsion is normal. We're heading direct north, out towards the Caribbean. We broke the sound barrier and reached Mach 1 after 30 seconds.
Acquisition de la télémesure par la station de Saint-Jean-du-Maroni.
picking up the signal at the station in Saint-Jean-du-Maroni, which is here at the Space Center, or just outside it. We can hear the rumble of Vega reaching us. The job of the first three stages is to get us away from the Earth. Vega is pushing itself away from gravity. And we need a lot of firepower to do that. We're burning the P80 first stage. P for premier étage. It's all going normally according to plan. Premier étage means first stage. 80 is the mass of propellant. Roughly, it's actually 89 tons. Bottom of the screen, our altitude on the left, 53 kilometers above Earth. Our distance is a straight line if you were to draw a straight line from the pad. And here we are separating the first stage, it's burnt its fuel, and we've switched on now the second stage. The Z23 burns for about 1 minute and 40 seconds. Z for Zefiro, which is an Italian wind, a bit like the Sirocco or the Mistral. 23, because it burns 23 tons of solid propellant. Our speed on the bottom right, nearly 3 kilometers per second, not per hour, per second. We're getting close now to what we call the Kármán line. That's 100 kilometers above Earth. We've just hit it. It's named after the Hungarian-American engineer, aerospace engineer, Theodor von Kármán, and it's the border with space. Basically, the higher you go, the thinner the atmosphere becomes, and the faster an aeroplane has to travel to stay up. Once you get into space, the air is too thin to support wings. And top right-hand side is the trajectory, showing us the flight path, if you like, and the white cross is the actual position of the launch vehicle.
Séparation Z23.
Separation of the Z23. Ignition of the next stage coming up, the Z9. There it goes. And then we can expect the fairing, the nose of the vehicle, to fall away. So we no longer need the fairing because we are effectively in space. We don't have enough friction anymore to cause us any difficulties, so the satellite is safe to be exposed to space. Now, Vega is particularly well suited to launching Earth observation satellites. This is the 23rd one to travel on board this versatile light launcher. And there are 9 more in the order book. Over now to the manufacturer, Avio.
The Vega launcher is the smallest of the European launchers operated by Arianespace. It has set a world record for small launchers in terms of precision and reliability, with 10 perfect launches in a row from its maiden flight. This high level of confidence has led Arianespace to recently sign a new contract for 6 Vegas and 4 Vega Cs for a total of 10 flights to occur between 2019 and 2021. I am now in our plant in Colleferro, where we produce both Vega and the boosters of Ariane. Here we are developing Vega C, which will fly for the first time in 2019. Behind me, you see the first Zefiro 40 solid rocket motor ready to be sent for static firing test. The Zefiro 40 motor is the second stage of the new Vega C and is nearly 8 meters long, has a diameter of 2.3 meters, and contains around 40 tons of propellant. The loaded case will be sent soon to the test bench for static firing. The Avio team, together with its industrial partners, Arianespace and ESA, are ready to demonstrate the strengths of Europe's collaboration in the space industry. I therefore wish the best success to the 11th mission.
La trajectoire est normale.
And the first 3 contracts for Vega C are a constellation for Airbus, an Earth observation satellite, and a Cosmo SkyMed second generation, which was also built by Thales Alenia Space. Separation now of the Z9 third stage. So the main propulsion phase of the flight is now over. We've got away from the Earth, and the upper stage, the AVUM or AVUM, is getting ready to switch on its engine in roughly 1 minute. The flight path takes us north, heading up over the Caribbean, along the east coast of the US and Canada. And we cross the Arctic and come back down to the west coast
Acquisition de la télémesure par la station de Bermude.
of Australia. And he's announcing that we are picking up the signal at the ground station in Bermuda. It's a Caribbean island, and we're using telemetry to track the vehicle. During the flight, Vega sends information to ground stations along its path. And they send that data here to the teams at the Guyana Space Center, which allows Arianespace to monitor the flight in real time. So the AVUM upper stage is waiting to switch on its engine. Here we go. Scheduled.
Premier allumage AVUM.
And we have confirmation that the AVUM upper stage has now switched its engine on for the first of 2 burns. It's going to burn for nearly 8 minutes. So we started the next phase of the journey. Observation from space is vital for helping us to better understand our planet, and the Mohammed 6A satellite will play an important part in that. Morocco is a modern society focused on the future with a very real commitment to environmental principles. And of course they hosted COP22 in Marrakesh this time last year. And if you've been to Morocco, you will know that it is a truly magnificent country with mountains, beaches, deserts, and it has a rich and important biodiversity and a long cultural history spanning several thousand decades. It's blessed with breathtaking landscapes.
Top à 0 moins 4 minutes.
He calls out all the major events, and he's just called out the beginning of the last 4 minutes, the synchronized sequence. Computers are now controlling all the final checks in the countdown, and they manage an impressive list of operations. All of that information is sent to these boards. We call these the status panels, and they are representing the 3 main systems across the base: the rocket and pad, the satellites, and the range. And a quick translation for you. The base at the top, logistics, safety. Mesure is the telemetry. Localization is radar. Telecoms, obviously. Ensemble de lancement is the launch, the range. And then, of course, the Vega launcher, the weather, and our satellite. The teams...
Top à 0 moins 4 minutes.
He calls out all the major events, and he's just called out the beginning of the last 4 minutes, the synchronized sequence. Computers are now controlling all the final checks in the countdown, and they manage an impressive list of operations. All of that information is sent to these boards. We call these the status panels, and they are representing the three main systems across the base: the rocket and pad, the satellites, and the range. And a quick translation for you. The base at the top, logistics, safety. Mesure is the telemetry. Localization is radar. Telecoms, obviously. Ensemble de lancement is the launch, the range. And then, of course, the Vega launcher, the weather, and our satellite. The teams in the Launch Control Center are watching over all of these operations. The Launch Control Center is based close to the pad, about roughly 1 kilometer. And they're in a protected blockhouse. And they are, of course, concentrating hard at this point just before the launch. Once Vega has lifted off, it will take approximately 55 minutes to deliver the Mohammed 6A satellite to its orbit in space. And after that, the satellite will continue orbiting on its own, on a sun-synchronous orbit. 2 minutes now, Vega standing tall. We have 3 working launch zones here at the Guiana Space Center, 1 for each rocket. And this is the Vega launch. The Mohammed 6A satellite is the result of very important collaboration between Europe's 2 biggest space industries. Thales Alenia Space as system prime contractor and Airbus as co-prime. Here's the CEO of Thales Alenia Space, Jean-Louis Gall.
I'm delighted and very proud to share with you this exceptional moment in the life of a space program, the launch of a satellite. The Mohammed 6A satellite will be an important infrastructure for the Kingdom of Morocco, availing itself of a very powerful Earth observation system for civil and government applications. Undoubtedly, this satellite will boost the Moroccan economy and will be the first step towards a constellation comprising 2 satellites built by Thales Alenia Space as prime contractor of the consortium and Airbus as co-prime. On behalf of our industrial consortium and of the Thales Group, I'd like to extend my warmest thanks to the Kingdom of Morocco for the trust placed with us, as well as the teams of Thales Alenia Space, Airbus, Arianespace, and all our industrial partners for their tremendous work and quality of our cooperation. This demonstrates the excellence of the French industry in this field.
And today is the 150th time that Arianespace has launched a satellite that Thales Alenia Space has built. And there are 15 more Thales Alenia Space satellites in the order book, so it's a very long and fruitful relationship. Coming up to 15 minutes into the flight, nearly 300 kilometers above our Earth. We've traveled a distance along the ground of 5,000 kilometers, and our speed is nearly 8 kilometers per second, ladies and gentlemen. That's fast. We're burning the Avum upper stage. It's getting ready to switch its engine off in roughly a minute's time. It actually uses a clever system called orbit-optimized guidance attitude to stay on track. It continually recalculates its position to make sure that it's exactly on the right course. And then if it deviates, it corrects its position and comes back to the correct trajectory. And we have confirmation there that the Avum upper stage has now switched off its engine. So we're entering what's called the first ballistic phase, and ballistic means without propulsion. So we're traveling high enough and fast enough to cruise without the engine, which we're doing for about 36 minutes. And if you might have noticed back there that the upper composite, that's what we call the upper stage with the satellite attached, was actually rotating. And that's because it's in what we call the barbecue phase, rotating as if on a spit to maintain thermal homogeneity, to keep even temperatures. As you can imagine, it's very hot when you're facing the sun and very cold when you're facing space. So the Avum upper stage will switch its engine on again 52 minutes after liftoff for a second burn. But for now, we're going to take a break and come back to you roughly 10 minutes before Avum switches its engine back on again. And our live commentary will resume at 2:26 in the morning, Universal Time. That's in Morocco as well, Morocco time. And that's 11:26 in the evening here in Kourou. We'll see you back here in 26 minutes and leave you with a replay of that beautiful launch.
Perte attendue de la télémesure lanceur pour environ 31 minutes.
Hello again and welcome back. You join us live at the Guyana Space Center and we're orbiting the Mohammed 6A satellite for Thales Alenia Space and Airbus for the Kingdom of Morocco. And we're nearly 44 minutes into the flight. We've been coasting without the engine for just under half an hour. This is called a ballistic phase, travelling without propulsion, without the engine. The AVM upper stage, which is what's left of the launcher, is scheduled to switch its engine back on again in about 8 minutes or so for a short burn before getting ready to start the process of separating the satellite. That's all to come, but first let's take a look at the story so far. We lifted off from the pad 44 minutes and 40 seconds ago from the Guyana Space Center on board a Vega launcher. VV-11, flight number 11, the 11th Vega to launch since it took to the skies in 2012. It was a perfect liftoff. The first 3 stages flew according to plan, each one burning its propellant. The propelled phase of the flight lasted 6 minutes and 30 seconds, and that got us into space. The next phase started when the AVM upper stage switched its engine on and took the wheel. Its job is to deliver our satellite to its orbit. Then it switched its engine off and we have been coasting ever since in a ballistic phase, coasting without the engine. It's due to switch its engine on again in about 6 minutes, and it'll start separating the satellite roughly 3 minutes later. Satellites and their associated ground systems are huge and complex engineering projects, and building them involves a range of different contractors and companies all working together. The Mohammed 6A satellite is the result of excellent collaboration between the industrial teams, Thales Alenia Space and Airbus, and the multidisciplinary Moroccan teams. In fact, these teams have been working together for 4 years. And it's the quality of this excellent teamwork which has allowed the development of an advanced satellite with very cutting-edge technology. Building a satellite system is a feat of human engineering, and it's also quite an adventure for all those involved. Thales Alenia Space and Airbus have led the teams.
Hello, my name is Jean-Marie Buxabelt. I'm the Thales Alenia Space Program Director, and I work alongside Didier Radola, my counterpart at Airbus. Together, we'd like to review the range operations of this campaign. First of all, I'd like to thank all the teams who contributed day after day to this major program for the Kingdom of Morocco. And I'd like to extend a special greeting to the Moroccan team in charge of the program, to our teams in Cannes, Toulouse, Aix-Charleroi and Madrid. And I'd also like to thank the representatives of the French administration who assisted us in this program for their input on regulatory matters.
Hello, Jean-Marie. Of course, I'd like to join you in this round of thanks. The project has been very well managed, and I'd like to insist on perfect coordination with the Moroccan team in charge of the program for rising up to this challenge efficiently, competently, and always with a constructive frame of mind over the 4 past years. Thanks to all the stakeholders, we are here today right on time for the launch of the Mohammed 6A satellite.
In order to develop this satellite, a specific organization has been put in place between Thales Alenia Space and Airbus. This is not the first time that this has been the case, as we've had the opportunity of working together in the fields of telecommunications and observation. To illustrate this partnership, I'd like to share just one example. Every time a difficulty would come up, we'd together evaluate which partner would be best suited to solve the issue in the overarching interest of the project. This is a very different relationship than a standard client-supply relationship, and this worked wonders.
For the range operations campaign, we've worked, as we always do with Air and Space. The satellite and launch vehicle teams are used to working together and have showed how professional they are. We would like to take this opportunity to thank Air and Space and CNES for their efficiency and reactivity in the course of this campaign. This launch today is not the end of the program, just a passage between the terrestrial phase of development and testing of this satellite and its operational phase on orbit, and we all hope that this passage will be a real success.
And now let's wish good luck to the Mohammed 6A satellite.
So some really important teamwork there. We are tracking the launcher, as we said earlier, using telemetry, and we're coming into the range shortly of the new Norcia tracking station. It's an ESA, that's the European Space Agency, deep space tracking station, 150 kilometres north of Perth in Western Australia. And it's used for communications for scientific space probes. It was used for Mars Express, Rosetta, which you remember landed on a comet, Venus Express, and Gaia, amongst others. It has a 4.5-metre dish.
Acquisition de la télémesure pour la station de Norcia en Australie.
There we go, confirmation. It's picked up the signal there, and it can see objects 100 kilometres away. And the tracking stations send the information, the data, to these teams here at the Guyana Space Centre. This is the CVI, the Real-Time Visual Control, or Immediate Visual Control Team. They monitor how the flight's progressing in real time.
Tous les paramètres à bord sont normaux.
He's telling us everything is going normally. And they pass that information on to the Range Operations Manager in the Mission Control Centre, so that he can then announce the confirmation of major events to everybody listening across the range. They also analyse the information after the flight to see how things can be improved, and that's called the Level 0 Flight Evaluation. Over 51 minutes now, getting closer to ignition of the AVM for its second burn. You may have noticed we were twisting, and for anybody who's joining us, we can see there that we are still in the barbecue phase. The satellite twists as if it's rotating on a spit to keep the temperatures nice and even. The second burn of the AVM upper stage will be to circularize our orbit. At the moment, we're on an elliptical orbit. That's an oval shape.
Deuxième allumage AVM.
There we go, we've switched the engine on again. So now we are going to burn for just under 2 minutes. So to turn our egg-shaped orbit into a circle shape,
Tous les paramètres à bord sont normaux.
We need this short burn, and he's telling us that everything's going according to plan. The AVM upper stage is the smart stage of the launcher, the
La
clever bit.
trajectoire est normale.
He's telling us the trajectory is normal. Its job is to deliver the spacecraft to a very specific orbit. In fact, it's designed to inject different payloads into different orbits. And to do that, it can switch its engine on and off up to 20
Il reste 30
times.
secondes de propulsion.
30 seconds of propulsion left. It uses little nozzles which give bursts of hydrazine gas to help it to orientate itself, and that way it can move in every direction. There's a good image of the New Norcia tracking station down there on the west coast of Australia. This is the station tracking the separation and all these activities now. The men and women there focusing hard.
La propulsion est normale.
Normal propulsion. Curvature of the Earth and our atmosphere, that very thin blue line.
Deuxième extinction, Avum.
And the Avum upper stage, or Avum, has switched its engine off. And we are now in the orientation phase, getting ready now to release the satellite. We are on orbit, traveling there at bottom right of the screen, 7.63 kilometers per second at an altitude of 630. We've traveled nearly 18,000 kilometers from the pad in a straight line along the ground. The upper stage has to release the satellite onto a very precise orbit so that it can then continue on its own. And you can see on the top right-hand side of your screen our trajectory. You can see how we started by climbing very steeply, then we plateaued out for a bit, and then we climbed higher again. And the cross is the actual position of the launcher. Looks like it's all happening very slowly, but of course it's actually happening very fast. We are hurtling along at just under 8 kilometers a second. We have separation of the satellite. Mohammed 6A satellite. The Kingdom of Morocco has a new satellite. Congratulations to everybody. The Mohammed 6A satellite is now heading out on its own. A culmination of many years of work for some and the beginning for others. Shortly the satellite will start deploying its solar panels, unfolding its wings, just like a butterfly emerging from its chrysalis. After 4 years on Earth, from concept and design to construction, the satellite is now starting its new life in space. It's an important day. Our warmest congratulations to the Mohammed 6A satellite teams and the Kingdom of Morocco. Here was the launch about nearly 57 minutes ago. We lifted off from the pad at the CSG, the Guyana Space Center, with a perfect liftoff. The 11th successful launch in a row for Vega. 8 of those for Earth observation, and today is the 13th Earth observation satellite to launch on board the light lifter in the Ariane space family. The the Mohammed 6A satellite becomes the 26th satellite to be launched by Vega. Lots of smiles there. Everybody deserves a big pat on the back for a job well done. The Mohammed 6A satellite is going to do some very important work. It's an Earth observation satellite, and it will be used for mapping and land surveying activities, for regional development, agricultural monitoring, the prevention and management of natural disasters, very important, and equally important, monitoring changes in the environment and desertification. Right now, the operations teams on the ground are piloting the satellite from the Mission Control Center in Morocco. They've taken on effectively flying the new satellite, and our very best wishes to them for the next phase of their operations. This is a very successful mission. All the team